animator versus the machine.
Begin.
All right, on today's episode, we have a very special guest. He's an old classmate of mine, and who now lives in Toronto, works at Guru, or used to work at Guru Studios. His name is Josh McEvoy. Thanks, man.
Hi, thanks for having
All
me.
right, so no problem, buddy. Tell the people a little bit about yourself.
Basically been an animator for 9 years in the industry. I've been mostly working out of Toronto, mostly at Guru Studios. And I've had an interest in AI since about 2017-18. And I've kind of, just recently in the last year, I've kind of taken a new shine to it, just with all the tools that are coming out.
All the new revolution of AI that's happened recently. All right, so to explain to the less techno-savvy people out there who are fearful of AI, how does it work? Like, what is diffusion to begin with?
Okay, so I have included some images, so maybe I can.
I'll
Cool.
magically put them in. Yep.
Okay, so I'm just gonna try and go through them in order of what I think would be easiest to teach. So the first one is convolution. So each of these three colors here are RGB, the three values of images, and what's happening here is something called convolution. So you can see that there's a window that moves across the image, and then it takes information and condenses it into a smaller form. So if you go to the next image, you can kind of see what the kernel is moving across the image. And it's a blue. On the blue one on the left is the image, and then the right is the output. So you can see that. I think this is just doing addition here. This is just kind of a simple example of it. But you can see that it's adding. I believe it's multiplying the values with the thing, and then getting an output. So, for example, the first one is 12. That's the output. So that's simple. I'm doing a simple animator's version of AI.
Perfect. That's what I want to hear.
So in the third one, this is something called an autoencoder. So right now it's also known as a VAE, a variational autoencoder. So you have, for the sake of diffusion or stable diffusion, you have your three inputs, RGB, and then it condenses it into, it's kind of like a bottleneck, or an hourglass. So it will go through it, and then it will has two parts: the encoder, which encodes it into compressed, up to 64 times compressed, and then the decoder, which for the sake of stable diffusion brings it back to what it was. So it's basically compressing information and then recreating it back to its original form. And you might say, what's the point of this? Why would I need an AI model that compresses information and then returns it back to its original form? For example, one good reason is just sending information. Like if I wanted to send information, it's a smaller form, it's a smaller size in the latent space representation. So I could send you the latent space representation, and then you could decode it with the same decoder, and then you'd have the full image. But for stable diffusion, the reason they do this is because it's easier if you compute it in what's called the pixel space. It would be very compute intensive. But when you compute in the latent space, it's 64 times less computation. So what they do is they compress the image into what's called latents, and then they operate in the latent space. And then when you're done operating on the latents, like when you have your image, it's decoded through the autoencoder back to your output image. Or like if I was generating an image, for example, I wouldn't use the encoder at all, and I'd just start with noise in the latent space, and then it would denoise that noise, and then it would run that noise through the decoder, and then I'd have my output image, my beautiful piece of art.
All right. So that was a lot to take in.
Yeah.
So let's simplify it in one sentence if you could.
Mhm.
Like, so you take an image,
Mhm.
it gets broken down, pixelated, and then and unfocused, and then when it gets refocused, it's to whatever you want it to be. Is that more or less?
Yeah, well, I'm trying to. There's 3 parts of Stable Diffusion, and this is the first one.
Okay.
The first one
perfect.
is the VAE, or the variational autoencoder. These are the three parts of the model that you'll be using basically as an artist. So the VAE is basically to compress images into latents, or to decode latents back into images. So think of it as that's the first part. Okay, so the next one is called the UNET. So inside the latent space representation of the autoencoder is a little neural network that is shaped as a U. So it's kind of the same thing as the autoencoder, except imagine this is like the hourglass shape, and then we pull that down, and then we add what are called skip connections. So basically, it's a U-shaped network. That's like how we visualize it. And then at the beginning of the input, it also connects to the output. And then it downsizes it with convolution again. And so you can see the first image is 64 by 64. It's 572 by 572 pixels, for example. And then it runs it, does it convolution, and then it makes the image smaller. And then so as it travels through the UNET, it kind of goes down, and then it goes back up, and with the skip connections. So the UNET is basically what generates the images. So when you would be generating an image with Stable Diffusion, you'd be using what's called the checkpoint file, and that would be this.
Okay.
So
yeah, go for it. Oh, go ahead. Sorry. No, go for it. Go for it.
You had a question?
Oh, I was just gonna say, is most of the AI that's out there that uses like art and stuff, like Stable Diffusion, or give me a name of the other ones. I just blank right now. Midjourney. They all use the similar process, I'm assuming.
Yeah. This. Okay. Well, I actually can't say for sure because I'm not sure how the other ones work, but this is how latent diffusion models work.
Okay.
Like
latent diffusion.
Yeah.
Okay.
So first, we're doing diffusion in the latents, which is what we just learned happens in the autoencoder. Okay, so basically, this is the same thing basically as autoencoder in the simple sense, but it has skip connections. And what the skip connections do, a paper just came out called Free U, where it learned that, what I learned, at least through it, reading it, was that the skip connections are more they learn more details, more like textures or higher frequency details of an image. And then the actual UNET itself learns more of the 3D representation of things. So like, for example, if I was generating a face, it would have like the 3D structure of a face would be learned through the UNET. And then the skip connections would be more for the high details, like for example, freckles or something.
So could the UNET understand a hand, like the structure of a hand then? That always seems to be the issue.
Yeah,
right? Like they can't do hands.
I think the main problem with that is, I think they need better data sets for hands, because I don't think there are many data sets of hands, especially hands that are holding stuff or doing things that hands do. Like most of the data sets are maybe just like a flat hand, right? Or like they're probably medical images. Yeah. So there could probably be better data sets for hands. I know some people who have fine-tuned the network with their own like images, of their own like data sets, and they've showed quite good results. So it's not a I wouldn't say it's like for any reason like a showstopper. It's possible, I think.
Yeah, it's not the AI's Achilles heel here.
Yeah,
it's just like,
it's not like it's not the reason to drop the whole thing, I'd say.
All right, so then what's part 3 then? We did part 1, part 2.
So this is part 2. Part 3 is something called clip. So let's see here. I don't actually have any images for this. Maybe if you go to image 6, you can see the whole. So 6 diffusion inference. So basically, these are the 3 things here. The blue is clip, the yellow is diffusion, and then the green is the VAE. So when I'm running what's called inference, or when I'm generating images, I input text into a prompt, for example. So here it says aircraft are performing an air show, and then clip is something that was created by OpenAI, and Stable Diffusion uses clip to take a text and give it what's called a text embedding, and it has a position in a theoretical space, a positional encoding. So like things that are similar to each other could be close to each other in that space, for example. So the text encoder embeds the prompt into text, and then it conditions the. So also you see at the top there says a noisy image. So that's how all images with latent diffusion models, such as Stable Diffusion or Midjourney, they start with complete noise. And then the diffusion model runs that the noise over and over again in steps and removes the noise from the image that doesn't exist yet, but that you've prompted on the input. And then once you've done a certain amount of steps, which you can, and there's different things called samplers, which do different. It's basically math that I probably wouldn't be able to describe, but I think it's differential equations. But
okay, sure. I'll take your word for it.
Yeah. So will I. So it does a bunch of time steps, and it just diffuses the noise in steps. And then once you've done a certain amount of steps, you run that noise, the latence, through the decoder, and you get your image, which is the air show there. So that's basically how it works. One thing I want that is a good visualization, I think, for people is if you go to 3C. This is called gradient descent. So this is an example of how neural networks, a visual example of how neural networks learn. So the parameters for a neural network, not the parameters, but the way in which a network learns is by something called gradient descent. So there's something called a loss function, or some objective that the network has to learn. So for example, with diffusion, it learns how to remove noise from an image. So when you're training a diffusion model, you have an image that you're training on, and it adds noise to it in steps, and it learns how to reverse that process. And so it's called stochastic gradient descent. So you'll if you see the top at the point with the black dot there, it moves in steps as it trains, and it's trying to get as low as possible on the loss surface. And if in theory, if your loss is low, it's kind of like golf. You want the lowest score possible. So it will do it in steps as well when you're training. So you'll feed it information, and then it will calculate the gradient, or the slope of the loss curve that it's on, and then it will take a step in the position that's down. That's a very simple definition of it. So when just imagine this, when you're training something, you're trying to tune the weights of the network so that the output for the loss function is as low as possible. Okay. And if you go to 3D, you can see this is an example of what the loss surface will look like with skip connections on the right, and then without it on the left. So it kind of averages it out. If you remember in the UNET how they had skip connections, or the lines that connect the bridge between on the U, it's a lot easier to find which way is down when there's not all this noise, for example. So it kind of averages out and smooths it out, so you can learn faster. And I think that's the basics of it from the images I showed. There's some other stuff too,
Perfect.
but I can mention if it comes up.
Sure. There you go. Phantom listeners, you just had a crash course in computer science.
a visual course.
A visual representation, yeah. So, like, I know the main reason people fear generative AI is because they're like, oh, it's gonna steal jobs. It's gonna steal, like, especially animators. Like, oh, it's gonna start animating.
Mm-hmm.
Do you see this as an issue? Because, like, when I look at generative AI, I see it more like at least right now, I see it like almost like a filter. It takes a pre-existing thing and maybe moves parts, but doesn't necessarily animate. Right? It's just like almost like this like underwater feel, like. In your opinion, what would it take for AI to, quote unquote, like actually animate with the 12 principles, and not just moving parts? I know that's super advanced.
Yeah,
like,
I'd say like the first thing it needs is data, which we have lots of, but it's not organized in a way that a machine like could learn from right now. Like it has to be labeled and stuff. So I don't know if it will be happening anytime soon. But right now, I feel like we have an incredible tool that we can use. It's all. I find it's just a tool that you can use to manifest your intent. Like as an artist, I have an intent that I want to create something, and if I can use the tools to generate that, that's showbiz, baby.
It's very true. You're not wrong. Like there's always. Like you're always going to use the technology of the time to create things. From like Disney using rotoscoping in like the 40s to the photocopying era of Disney, where they're just like, oh, photocopy, let's save money.
And the whole ink department just gets sent out the door.
Yeah.
But then the other jobs get created too. I know it is scary because a lot of people, I feel like it just kind of came out of left field for them.
Right. Like and very much so, because you're like, it was just like, oh, I can type this in and I don't need a background artist anymore. Like, what the fuck?
Yeah, like for me, my experience was I was interested in AI in 2018, but the images, like back then, there was the state of the art was something called like StyleGAN, which is just faces, and that's all the model could create was faces of people, right? But then just last year, I was on the internet and I suddenly saw like a bunch of beautiful pieces of art and that were created by something called Stable Diffusion. And I was like, okay, maybe it's time to get back into this because it's clearly changed a lot in the last couple of years.
Well, yeah, like it definitely was like this. It's like, oh, it's like it's for hobbyists, and then all of a sudden it was like, oh, and now it just spiked. Now it's like we're affecting everything and everyone.
Yeah,
I did.
Sorry,
go ahead.
No,
go ahead. No, we're not doing this Canadian standoff. Go ahead.
I didn't actually. I forgot what I was going to say. So you go.
Oh, okay, perfect. Oh no, I forgot too. So don't worry about it.
Here, let's address our notes.
Yeah. Oh, it doesn't matter.
We're too kind.
Yeah. So yeah, like it was this thing that came out of left field, and then people were just caught off guard. Right. And I know that scares a lot of, like, especially with people that it directly affects, like I said, background artists, painters, like those type of fields are like, those are the directly affected ones. But it's also affecting other aspects. Like I did an episode where I posed as a mysterious, like as like a professional in AI. It was just me asking ChatGPT questions and using an AI voiceover to act myself, and then I just made myself look like I was in witness protection with like the black silhouette, so you can see who it was until the very end. But it's just like, the big reveal is just a sock puppet, so whatever. With like an AI written on top of it, and I'm like, yeah, it's fine. But even then, but voiceovers are starting to be affected by it. When I talked to Rob Tinkler, he was like, yeah, it's starting to affect some aspects of it, and that's primarily where the strike came from.
Yeah, I think one thing is it will disrupt our entire pipeline eventually, but right now it's not disrupting everything equally, which makes it like if it disrupted everything equally, we could just use it and there wouldn't be any displacement. We just train everyone and then we just make more cartoons. But if AI can just do backgrounds, for example, which I think it could do, production ready backgrounds right now, like that's a bunch of people who are background artists who suddenly have to compete over the one person who can do their whole job as a team. And then the animators obviously can't, like, animation doesn't really work with it quite yet, so they'd still have to animate it. So there'd be like the bottleneck is now animation, I think.
Yeah.
For now.
Yeah, because even riggers, I'm like, yeah, maybe, but I'm like,
I don't even
guess some
think
aspects.
Yeah, I don't even think that rigging will be a job in the future.
No, that's what I was gonna ask. Because like, my next question was like, I've seen maybe not AI, but like just smart tech, like animation bot in Maya, where you can download it and it will give you the code, like it will give you the in between, right? The properly you can tween it and you can do all these fancy things. But like that's a software that calculates everything you need to do to simulate animation. So they have that for Maya and Blender. So my question is, do you think something like that with AI will be in 2D software like Harmony or Moho? And what are the roadblocks from that?
I actually don't know if in the future we'll use 3D geometry at all. Like that's how disruptive this could be. Yeah, like, because why would you spend all this time modeling something or creating a 3D model of something if you can just have an AI model that understands 3D representations of something and it can turn that around?
Yeah, but then at the same time, it's like, why do people still 2D? Like, why is like Studio Ghibli still draw by pencil? You know what I mean? When you have paper, you have puppets.
Yeah,
it's aesthetic.
But if it's cheaper, then I think it will.
Sure. There'll always be like the cheaper option. That's always a thing.
But it's like, not also worse too. I think it would be better.
No,
it'd be.
No,
cheaper.
I'm not saying it would be worse. I'm saying if everyone, like, you're gonna have this, it's almost like the early '90s feel of 3D animation, other than Pixar, where everything started looking. Like beside Pixar, where reboot, where like everything started looking the same, and you're like this weird, almost floaty, until like they started ironing out the kink. Like if you look at like first season of Reboot and first season of Beast Wars, the animation's not like super great. It's like a little floaty, and you're like, but you give it a pass because you're like, it's so good. You're like, don't worry about it.
Yeah.
Or
but also back then it looked like real to me.
Yeah. Like, whoa. Yeah. Like as a there was nothing to compare it to, right? You were like, exactly. Yeah. This is like 3D space. And like, my dad was an electrical engineer, and he was like, I love Reboot because I understand all the computer jokes. I'm like, shut up, old man. Let me watch my show.
I'm not learning anything, Dad.
No. Yeah, I don't care about the 0011 joke that's going on in there.
Yeah, I don't like. I feel my concern is that this is just happening so fast, and it's progressing so fast that I don't know if the transition will be the same as it was from 2D to 3D.
Right. That's what I think a lot of people are concerned about. Is when I've talked to other people, they're like, "Oh, is it like who've been in the business for like 30, 40 years?" And I'm like, "Is this similar to like is this panic and chaos similar to what it was like when 3D was introduced and when digital like paper puppets was introduced, right?" And a lot of them are like, yeah, it's similar, like it feels the same, but it's not the same at the same time.
It's like the momentum of it is it changes things, I think.
Yeah, like it is progressing ridiculously quickly, and it's like within a month it could be. Yeah, go ahead.
No, you finish it. Within a month. Yeah, within a month it could be like a game. We could be out of it.
Yeah, in a month from now you can be like, oh, and it's totally changed. Now it can do hands, it can do fucking everything. Like, oh, okay, cool.
I think honestly the only thing that it needs to learn, like, or we need to train it to do is, at least for animation, is to animate with temporal consistency. Like it has to be able to maintain the image that it's, which I don't think that we're that far away from, because from what I've learned, like here maybe is the time to show those images that
go for it.
Like, so okay, so right now there's something called motion modules, which are things you add on to Stable Diffusion. You kind of splice it into the model, and it can have understanding of how things move. So here's 3 examples. I didn't make these. These were made by a user called Manshuti, who, and the motion module is available to download on a website called Civit AI, which is great for downloading I haven't even mentioned what lores are. Like that, just there's a lot to explain.
This well is deep, boys. Let's keep going.
Okay, so here, these are things that I think would be useful to explain, just as ways to get finer control and to, as an artist, to control the model and its output. So there's something called low rank adapters, or LoRa for short. And so basically, if you look at the images of the stuff, number 7 is LoRa. So basically, it takes basically in the orange things on the right, they're called tensors, and there's 2 low rank tensors. So it kind of, again, hourglasses are a big thing in the AI for some reason. So hourglass shapes. So basically, you're training it's called a lower rank. So it's a lower dimension, so that you don't have to train as many parameters. So here's the LoRa that I trained on, the actress Jenna Coleman. So in the if you're familiar with Doctor Who, she's an actress in Doctor Who. So in the first one is the baseline images. So these are images of Jenna Coleman. So there's 3 images here that are real pictures of her. And then if you look in the second folder, there's this is Stable Diffusion XL's understanding of Jenna Coleman before I trained it. So it doesn't quite look like her. And then in the third folder is images of her that I generated with my low rank adapter that I trained on Stable Diffusion XL. So you can do, for example, her in a drawn style, like with the witch image. That's not. It's more. You can have her like wearing clothes, like a nun outfit here.
Yeah, I was like, is that from like The Sound of Music or something?
No, it's just. I did like an '80s horror movie.
Okay,
nun.
like The Exorcist or something.
Yeah, something like that. That's I can't remember what I typed exactly, but I was going for like a Brian De Palma kind of movie. Yeah, and so you can train not just people, but you can train styles, you can train outfits, you can train, and basically it's each thing that you train is a file that you just add into the network. So I could say have Jenna Coleman, and then I train Laura for a red dress that I want her to wear, and I can just kind of daisy chain these together, and then I can have an output, for example, that I wanted. If like, for example, I had a scene with a character that it doesn't have to be an actress. It could be like when I created like a cartoon character that I made too. And then I just daisy chain all these together, and then I could animate a shot with motion modules. And then there's also a thing called control nets, which are ways to control the output. So have you ever heard of these? Control nets. Okay, so one of the things I think will be one of the control nets I think will be most applicable to animation is called open pose. So it's basically a skeleton, a black image with a skeleton, in each bone, like in 3D geometry, is a different color. So it learns that if it says, for example, this bone is blue, so that is an arm in theory, and so it will kind of condition the latents on this image, and it will make a character in that pose. And what you can do now is you can feed those a video of those poses. So I imagine that you could, in theory, animate with your body. So it's kind of like stop motion with your body, and then you could take the footage of you animating with your body and run it through open pose and get the poses, like a sequence of poses, and then you feed that into a control net trained for Stable Diffusion, and then you could have, in theory, I imagine, an animation. With LoRa, you could have it in your character. Yeah, I think
Sure.
like there are examples of that. One great Discord, for anyone who's interested in, is it's called banodoko.ai. There's
all right.
Yeah, it's in the link on the thing. Like from what I've seen, like there's some pretty cutting edge work being happening in real time. Like people are making videos and art, and it looks fantastic in my opinion. Some of it looks bad, but some of it looks really good.
Sure. It's learning though, right? You gotta get it through all the shit before it starts becoming good.
Yeah, and it is just a bunch of people who are learning it in the same time in parallel. So if you have any questions too, that's a great place to ask.
Perfect. So you briefly mentioned pipelines.
Mm-hmm.
So what do you see AI being used in the pipeline, and like how would it work?
What I think the pipeline of the future will be is, so like let's say for example, I wanted to make a cartoon with AI. I would have to first take a pre-trained model like Stable Diffusion. For diffusion models, I think that Stable Diffusion XL and Stable Diffusion, like the previous versions of them, they're the only ones I know that have open weights that allow you to train. Like you can train with some other ones, but you have to train through their website, right? Like you give them images and then they. But this is the only one where I can train the weights. Like I have control over the weights and of the model, and I can train them and make my own stuff that I have agency over, right? So I imagine I'd take Stable Diffusion, then I'd train a checkpoint on or a LoRa, a low rate adapter on my style, and then I would take that checkpoint. I'd probably do what's called the dream booth of. So it's like it's training a whole checkpoint on my style. So anything that I would make from that is in the style. So for example, there on Civit AI, the website, you can get models that are based off of checkpoints of Stable Diffusion, but they're trained to be in a style like Dream Shaper or any of that's what it's called, the model. So I would train my own model, and then I would have train my LoRa's on characters that I designed. So you could either generate them through Stable Diffusion, or you could draw them yourself. You could take a picture of something and teach it, this is what I want. So there's really no, as long as you have an image of something, it doesn't really matter how you make it, as long as you have something to feed into the model to train it. And then I would train, for example, let's say I had a character, like let's call him Bob. I would train it to learn what Bob is, and then I would have a LoRa file that I can just feed into Stable Diffusion. So any shot that would have Bob in it, I would splice in the low rate adapter into the model. And if anything that I would need to train, that would have to be consistent. Like if Bob had an outfit like a hat that he had to wear or something, then I'd train it on that. And then I would use what I said before about the control nets and stuff to, and also the motion modules also learn some things. So if I said like windy, I could have my hair blowing in the wind.
Okay.
So I'd be mostly animating like the higher level features of the animation, and the motion module will do the other stuff like overlap and stuff like that.
So then, do you have control over? So like, say you type in like, I want my hair windy, right?
Mm-hmm.
Do you have control over that, or is it just generate it randomly?
They're also okay. So these are the you're slowly learning all the pieces that I've just used for everything. So there's also low rank adapters for motion modules. So I could train a motion module on wind. So if I could then I could tune, like I want more wind, I want less wind. So I could just tune a value between 0 and 1, and then it would be extra windy or no wind at all. And these are all just things that have to be trained. That's the hard part, is training all these, and then you can have a bunch of pieces that you can pick off the shelf or off the internet and compose them all into output or image or video. So that really brings down the cost of animation. Like if you just have to download a bunch of things and piece them together.
Yeah, I guess. Like, I don't know. I'm trying to like run some numbers in my head. I'm like, okay, I'm buying for this.
Zero.
I'm like,
zero.
I'm buying, yeah. If I pay for people versus like computer space, I'm like, okay, mm-hmm. And servers, I'm like, okay, let's figure this out.
Yeah,
it's
like the biggest thing is like GPUs. Like that's what you need.
Yeah,
is to do inference, and then a couple of big space hard drives to store all these files.
Yeah, it's almost like you're making a crypto farm, but just for animation.
Yeah. That's what I'm so excited about this winter is I can heat my house by training.
Yeah,
photos.
just
Yeah.
just
Oh,
constant
it's kinda hot in
humming.
here, yeah.
Oh, yeah, you're just in
Nice and
shorts. Like, hey,
cozy,
what's going on?
nice and cozy, sitting by my computer with a hot cup of Coke.
Until the power goes off, you're like,
Yeah,
no.
no.
Okay, so then, but like the big question that's like basically the big issue I've seen online is like everyone's calling this the Gen AI, right? Whatever, it's kind of a shitty name, but whatever. Um, they're upset and rightfully so that like it's grabbing its sourcing from artists' work online without credit and just stealing styles that are very similar. So what could be a solution to this? Is just like sourcing the artist like you would like in a paper, or do you give credit like what or should there be regulations?
I honestly don't think that it can be stopped. Like if like you as an artist, your intention is for people to see your art. And unless that's like in a room where no one can take photos or anything of it, it'll probably be online, and then people can take that and then they can train an AI on that. Like I don't think there's any way you could stop it. You could set laws and stuff, but at the end of the day, this is information and math, which is pretty hard to ban.
So if resistance is futile for the future, what skills do you think artists should learn, in your opinion, to adapt and survive?
I already got a list. So the first thing is first and foremost Python. It's the language that AI is used to program. Python is what is used to program most things, but most stuff, like the higher level stuff, is used in language called CUDA, which runs on the GPU. But I don't ever program in CUDA. I just program in Python. So that is the first thing you have to learn, I'd say. Not that's one. There's most of them are computer things, by the way. The second one is it's a tool called Conda or Anaconda or Miniconda. They're basically ways to manage your Python environments. So if I have a Python script, they'll have some dependencies. For example, a way to there's a let's say like PyTorch is one. It's a learning. It's a library for basically machine learning and deep learning. And it was made by Facebook a while ago, but it's since branched up to its new thing. So that's a dependency that's used heavily in Python. So you'd have to. It's like basically a box that you have all your dependencies in, and it runs in its own sandbox. Basically, that's what Anaconda is, and you can pick your Python version and stuff. One skill is definitely useful is learning how to use the command line on a computer. So like the text, the black text and the green black image.
As I used to call it, my dad always, I was in a hacker window. You're like, oh yeah, we're going to the mainframe.
I'm in. So that's mostly good just for using Anaconda and stuff. There are like front ends like Automatic 1111 if you've ever used it, or Comfy UI. You basically start those in the command line. So and if you update them, you can update Comfy UI through itself now, but you can update it through the command line too. So it's a very good skill to have, I'd say. One is Git. So basically, Git is a way to update repositories. So like, let's say I wanted to download Comfy UI, download it with Git usually from a website called GitHub, which is a website for sharing code with each other. So I can, for example, I can download the Git repository, and then anytime I need to update it, if there's a new update that comes out, I can just say Git pull, and then in the command line, and then it will download all the updates. And so those are basically the main three. I guess it's four things I said. So four things. And then one thing that is like you can use Windows, but I would recommend dipping your toe into Linux, just because that's what a lot of AI people use, like Linux, not Windows. I know a lot of people in the art industry use Macs, and Macs are actually maybe better than Windows, I'd say. But as far as AI goes, but I think I'd say Linux is king. So you don't have to necessarily know how to use Linux. In the future, it'll probably just be the backend that runs Linux, and then you'd be using Windows with Comfy UI or something, or some tool like that. But it would be helpful. Do what you want. Use your own operating system. But that's what I use.
Just do what you want. Don't worry about me.
Don't listen to me. Do what you want. But I'm highly opinionated towards Linux. Okay, so then the last four things that I think would be useful to learn is four Python libraries. So there's PyTorch, which I mentioned before, which is for a Python library for tensors and deep learning and whatnot, made by Facebook. And then there's three others that I find are useful. So these are all made by a website called Hugging Face, which is the go-to place for downloading models and stuff like Stable Diffusion. And these are accelerate, diffusers, and transformers. And all of these are basically ways like I can with transformers, I can basically in 5 lines of code download an AI, run it on text, and like say if I have like for sentiment analysis, if I have text and I want to say, is this positive or negative text, I can have in like 5 lines. I can have 5 lines of code. I can download a model from Hugging Face, and then it'll give me an output and say there's a 60% chance that this is bad or good text. Like,
oh, interesting.
So it really simplifies the amount of coding you have to do, and like if you learn these, I think you'd be honestly pretty powerful. Not powerful, but like you'd be a god.
Yeah, infinite power.
Yeah, you have the five rings of the 5 stones of Thanos.
There you go.
So those are tools I think. Yeah, those are tools I think artists probably don't know how to use, but I think would be useful if you want to learn in the future. But also, if you don't want to, don't do it. Don't listen to me.
No,
do your own thing.
So there we go. That's a keen, I guess, insight into the future that might be just around the corner, or
tomorrow,
a month from now. Yeah, who knows? So as we wrap things up, is there anything that we missed you want to say, or you want to say to the phantom listeners out there that are maybe sharpening their pitchforks or signing up to look at Python?
Yeah, well, put your pitchforks away. There's no need for that. I don't know. Like, I'm trying to. What would I say to someone who's afraid of the future? The future is uncertain. You likely will have to change.
Right.
I'm trying to think of how to proceed without getting a pitchfork in me. Right. The future is uncertain, but you'll probably have to change. Technology always changes. Art always stays the same, or maybe it doesn't. I don't know. I don't have any sage wisdom. I'm sorry.
No. Hey, at least that's very honest.
Yeah, I don't know. We'll see what happens. Learning can be fun. Try and enjoy it.
Exactly. Well, that's it. I want to thank our guests for contributing on our journey so far, and I want to thank you, the phantom listeners, for hearing us ramble around the water cooler. Come check in next time as we talk more about the subject of AI in the animation industry. Let's find out together. Don't forget, keep your eyes on the horizon.